Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about electronics chapter from Cambridge A2 Physics. In this lesson, I'll explain you how to draw circuits for the output devices such as light emitting diodes, or simply we can call them LEDs, and relay with the help of past paper questions. For this question, it is given to us that the output potential of an operational amplifier is monitored using an output device. An output potential can be positive 5 volts or it can be negative 5 volts. Part A is simply asking us on figure 10.1. So here is figure 10.1. We need to draw a circuit for the output device that consists of two light emitting diodes B and J. Diode B alone. Very important thing we need to understand, alone means only diode B has to emit light when V out is positive 5 volts, and diode G alone means only has to emit light when V out is negative 5 volts. So this is what is given to us. In order to answer this question, we simply need to understand what is meant by polarity of LED. Polarity simply means that if you look at this typical symbol of LED, you can see one side is marked as positive, or you can say this is anode side, and other side is marked as negative, or you can say this is cathode side. So it simply means the positive side has to be connected with positive terminal and negative side has to be connected with negative terminal of power supply. So in this case, this LED will be working. But if we connect in a wrong way, means we connect the positive end of this LED with negative terminal of power supply and the positive terminal of power supply with negative end of LED. In this case, simply this will not work. So this is main concept we need to understand to answer this question. Second thing, it is also very useful to understand what is the maximum value of current that can pass through LED, that is 20 milliamps, and this is a typical value. Also, we need to understand what is the maximum value of potential difference that we can apply across LED without damaging LED, and that typical value is 5 volts. Now if we have understanding of polarity of LED, then this question is just very simple. It's just based on polarity of LED. If we look at real image of LED, we can also find out which side has to be connected with positive terminal and which side has to be connected with negative terminal. If you look at this leg of LED, you can see this one is longer one and this is anode side. It has to be connected with positive terminal of power supply, and the other leg you can see this is shorter one and this is cathode side. This has to be connected with negative terminal of power supply. As you can see here now, I have already drawn this circuit, so let me explain to you so you can have better understanding about this circuit. For diode B, it was given to us that diode B has to emit light when V out is positive 5 volts. So it simply means that when this V out is positive, you can simply see that the positive end of LED is connected with V out positive. So this one will be conducting, mean this LED will be on. And it also given to us that alone means only B has to be on when V out is positive, and this is true because this end of LED G is negative and this one will not be conducting. So this is true. Now let's move on to second one. Diode G alone has to emit light when V out is negative 5 volts. So you can see now the negative, when the output, this output is negative, mean when this is negative, you can see now, so negative is connected with negative, so LED G will be conducting, mean this one will be on, but as this is negative now, it is connected with positive end of LED, so LED B will not be conducting, mean this one will be off. So this is how we can answer part A. Maybe you are a little bit curious about this resistor. Why do we need to connect this resistor in series with LED? This resistor, actually we call this is protective resistor. The purpose of this resistor is simply to protect LED, because the maximum current that can pass through LED means the typical value of maximum current, that is 20 milliamps. If current exceed than 20 milliamps, LED will be damaged. So in order to limit current, we have to connect protective resistor in series with LED. So simply its purpose is to protect LED. For part B on figure 10.2, we need to draw a circuit of the output device that consists of a relay and a diode, such that a high powered lamp is switched on only when V out is negative 5 volts. It simply means that when this V out is negative, this high powered lamp, this has to be on. And when this V out, this is positive, this lamp has to be off. So this is given to us, means this is condition, and based on this condition we need to draw circuit. And in circuit, simply we need to draw a relay and a diode. As you can see here, I have already drawn the circuit, and in this circuit you can simply see here we have connected one diode here and we have connected relay at this point. We have another diode that is connected here, and this diode, simply we call this one is protective diode. The purpose of this diode is to protect op amp from back EMF. So we can simply write down to protect op amp from back EMF. Now when this V out, this is negative, current will flow in this direction. When current will flow through this solenoid, this will be magnetized. When this will be magnetized, it simply means that this will act just like a magnet, and this switch will be closed. And when this switch will be closed, means this switch will be attracted and switch will be closed. When switch will be closed, circuit will be on. When this circuit will be on, this high power lamp also will be on. One thing more you need to understand is that these two diodes, they always have to be connected in opposite directions. Opposite direction simply means that when this diode is pointing down, this one has to be pointing up, and if this one is pointing down, this one has to be pointing up.